Hello everyone, let's solve a problem. So the problem statement is determine the inductance of a three-phase line operating at 50 Hz and conductors arranged as follows. Here we have three conductors 1, 2 and 3 arranged in an isosceles triangle. Distance between conductor 1 and 2 is 1.6 meter and distance between conductor 2 and 3 is 1.6 meter. Distance between conductor 1 and 3 is 3.2 meter. Diameter of each conductor is 0.8 centimeter. Also determine the capacitance and charging current per kilometer when the transmission line is operating at 132 kV. So here what we have to find out is inductance, capacitance and charging current per kilometer. Okay, and what data we have got. Frequency 50 Hz, it's a three-phase line, conductor diameter is 0.8 centimeter and the transmission line is operating at 132 kV. So here we have got the distance D12, D23, D31, 1.6 meter, 1.6 meter and 3.2 meter. Now first we have to calculate self GMD. Why? Because when we'll calculate the inductance of the line, the formula is L is equal to 2 into 10 to the power minus 4 ln dm by ds. So here dm is mutual GMD and ds is equal to self GMD. So how we'll calculate this ds and dm? So here we're calculating self GMD. ds is equal to r e to the power minus 1 by 4. Okay, so e to the power minus 1 by 4 is 0.7788 into radius r. So radius, we got diameter, so we will convert it into radius divided by 2 and we convert it into meter. So it is 0.004 meter and we'll put the value of this radius here and we'll get self GMD as 0.003115 meter. Then we'll calculate mutual GMD for three-phase unsymmetrical spacing and the formula is we'll multiply three distance that we have got D12, D23 and D31 and we will take its cube root. So we'll get the value as 2.015 meter and we'll put self GMD and mutual GMD value in the formula of this inductance, that is L is equal to 2 into 10 to the power minus 4 ln dm by ds. So what we'll get is, if we multiply, okay, we'll get it as 1.294 millihenry per kilometer, which is the required answer, that is the inductance. Then we have also asked capacitance and charging current. So the formula for capacitance per phase per meter is 2 pi epsilon naught divided by ln mutual GMD by r, farad per meter. So mutual GMD we have calculated previously, we will put its value 2.015. Radius we have got at 0.4 into 10 to the minus 2 meter and epsilon naught value is 8.854 into 10 to the minus 12 farad per meter. So we'll put all these values in the formula, then we'll get the final value as 8.928 picofarad per meter and we'll convert it into kilometer. It will be 8.92 into 10 to the power minus 9 farad per kilometer. And the formula for charging current is I is equal to V on XC, voltage upon capacitive reactance, and Xc is 1 upon 2 pi Fc. F we have got 50 Hz. C we have calculated as here. C we have calculated 8.928 into 10 to the minus 9 farad per kilometer. So here charging current I is equal to V into 2 pi Fc. Here we know how we get this formula, V into 2 pi Fc. So V is 132 kV. Okay, so V line root 3 V phase, and so V phase is equal to V line by root 3. So here we have line voltage 132 kV converted into voltage 132 into 1000 volt divided by root 3. So we will get phase voltage into 2 into 50, that is frequency 3.14 is pi, and here it is C. So putting all these values, we get I is equal to 0.2136 ampere per kilometer, which is the required answer.